In this video, we are going to solve another interesting problem. So the problem is, a unitary matrix U is expanded in terms of a Hermitian matrix H such that U is equals to e to the power I pi h over 2, and H is given by half, 0, root 3 over 2, 0, 1, 0, root 3 over 2, 0, minus half. Then U must be, and 4 options are given. So among these 4 options, you have to choose which could represent the matrix U. So if you want, you can pause this video and give it a try, then come back and see the solution. To solve this problem, let's start with the eigenvalue equation for H. So mod of H minus lambda I equals to 0. Here I is an identity matrix having the same dimension as that of H. Therefore, we can write determinant of half minus lambda 0, root 3 over 2, 0, 1 minus lambda 0, root 3 over 2, 0, minus half minus lambda is equals to 0. Now, if you expand this determinant, then you will get half minus lambda times 1 minus lambda times minus half minus lambda minus root 3 over 2 times minus lambda times root 3 over 2 equals to 0. Now, from each term, if you take 1 minus lambda common, then you will get 1 minus lambda times half minus lambda times minus half minus lambda minus 3 over 4 equals to 0. Therefore, from this equation, you can say that either 1 minus lambda equals to 0 or half minus lambda times minus half minus lambda minus 3 over 4 equals to 0. So, the first equation gives lambda is equals to 1. Now, the second equation simplifies to 1 over 4 minus lambda square plus 3 over 4 equals to 0, or we can say that lambda square minus 1 equals to 0. So, this is a quadratic equation for lambda, and we can get two roots from this equation. So, lambda is equals to plus minus 1. So, all the 3 eigenvalues for the matrix H are plus 1, and minus 1. So, if the matrix H has these 3 eigenvalues 1, 1 and minus 1, then we can say that the matrix I pi h over 2 will have 3 eigenvalues I pi over 2, I pi over 2 and minus I pi over 2. Again, we know that if lambda is the eigenvalue for the matrix H, then e to the power h will have the eigenvalue e to the power lambda. Therefore, we can say that the eigenvalues for the matrix U equals to e to the power I pi h over 2 are e to the power I pi over 2, e to the power I pi over 2 and e to the power minus I pi over 2. So, these are the 3 eigenvalues for the matrix U. Now, trace of U is equals to the sum of the eigenvalues. Therefore, we can write trace of U is equals to e to the power I pi over 2 plus e to the power I pi over 2 plus e to the power minus I pi over 2. Now, if we use the identity cos theta is equals to e to the power I theta plus e to the power minus I theta over 2, then we can write trace of U is equals to 2 times cos pi by 2 plus cos pi by 2 plus I sin pi by 2, as e to the power I theta is equals to cos theta plus I sin theta. Now, cos pi by 2 is equals to 0 and sin pi by 2 is equals to 1. Therefore, we can write trace of the matrix U is equals to I. Now, from the 4 given options, we have to check which matrix has the trace I. So, as you can see, the matrix given in option B has the trace I. Therefore, this is our correct answer. So, if you like my videos, please like and share them and subscribe my channel. And if you want to solve more problems on matrices and determinants, then please see the playlist. Link is given in the description.